Welcome back to the Foundation in C# course. We're currently in Module 8, and in this lesson, we're going to be covering API data access. So we've seen in the previous module how to create an API, but in this lesson, we're going to see how to use an API as a data source. Okay, so an API, when you design it, the API interface, the application programming interface, is kind of like the UI layer. But it's not really a user interface. I guess you call it a user interface because it's actually usually computer to computer, but that's the interface for your application, is that API layer. However, on the other side, when you create an application that consumes an API, the API layer becomes your data access layer. So it's kind of both types of layers. It's an interface layer, and it's also the data access layer. So we're going to create a very, very basic API and then consume it. And I'll also show you the API I want you to use for your work, which will be actually an external API. You won't have to create your own. We'll use one externally. So let's go to Visual Studio, and I have pulled back up the NoSQL DB solution because we're going to use the data access library of MongoDB. We're going to use that as our data source because I wanted to have something in here that was an actual real data source to see with our API. Okay, so we'll actually create multiple layers of this application. We'll have our class library that actually talks to the MongoDB, and we'll have our API that talks to the class library, and then we'll have actually an ASP.NET web application, a Razor Pages application that talks to the API. So to have three layers in here, really more than that, but three major components or projects that will be operational here. Okay, so let's start by adding an API layer. So right-click on Solution and say Add, New Project, ASP.NET Core Web Application, and we'll call this our sample API. It's going to be an API.NET Core 3.0. We'll configure it for HTTPS, but not for Docker, and no authentication. We're not going to go deep into creating an API with authentication, authorization, and all the rest. That's a little beyond the scope of this video. We're just going to create a basic API that has read and write capabilities. Now, in the real world, you would not create an API that has both read and write API access without having some type of authorization. But in our case, this is a small demo application just to demonstrate how you read and write once you're authorized. So let's create. And once this is done, we can close out the launch page. And we have here a weather forecast controller. We're going to get rid of this in just a minute, but let's set this as startup project. Okay. We're also going to add a dependency, add a reference to the data access library. Now let's create a controller, and we'll call this API controller, empty. We'll call this the contacts controller. And it says a problem. The error run selected code generator, package restore failed. Okay, hit again, hit cancel. Let's do a build. It looks like it's trying to do a package restore and it's having an issue right now. And it looks like there's a reference to a .NET Core 3.1 app when we're a 3.0. So the problem is that this library is a 3.1 app. If we change it to 3.0, it should not be a problem. similar pattern of creating this MongoDB access or MongoDB data access. But what I'm going to do is I'm going to put this into dependency injection. And the reason why is so I can just ask for it without having to. No, I'm not. I'm gonna create it right in line. Just make it simple because it does have initialization here that I don't want to go too far down the rabbit hole of doing. So what we're going to do is we have a table name called contacts in the database here. So we're going to need these values. So let's copy this first. And let's go to our contacts controller. And in here, we'll paste these. We'll not make them static. And we're going to hard code this to be that context, which is already hard coded. That's fine. Control dot here to add the using statement. And now in our constructor, we're going to need to have this instantiation here. Okay, so we're just following the same pattern we had before, but this time in a web app. All right, so we've got the hard-coded Mongo Contacts DB. We could pull that from app settings. We'll just leave it alone as it is. I do want an I configuration, and I'll show you why. Configuration for us, it's already set up. It already knows about app settings.json. So we don't need to do that. We just need to get the I configuration, which we can ask for in our constructor. And dependency injection will inject that automatically for us. So now instead of get connection string, we can say underscore config. Whoops. We'll have to swap this line in just a minute because let's do it now. We can't use underscore config until after we've assigned it a value. Config.get connection string, and pass in default. That's the connection string we want because that's the connection string an array. Notice the first square bracket. But we only have one item in here. That's Charity's record. So if I copy everything but the array brackets, I'm going to copy this. Here's the really cool thing. I can paste that later as a whole model. All right, I'm going to show you how to do that. But first, what we're going to do is we're going to create, let's just create one more, and that's an insert. We're not going to do all the different values because I don't want to spend the time creating an API, which we've already done in the previous course. I don't want to spend the time to create the API when you know how to create an API and you know how to call the like the MongoDB stuff. So it's just the talking to the API that's really the big question mark. That's the focus for today's learning. So we're going to create just one more, and this will be an insert. So we're going to say public void insert record. And the record is going to be a contact model. We'll call it contact. And we're going to mark this as an HTTP post. Okay? Now, if you're not familiar with different types, typically HTTP post is when you create a full record. That's like your, in the CRUD, that's create. Okay? Where get is your read. Put or patch, those are updates. And delete is delete. Okay? So you have options here on which type of verb to use. Put, patch, options, get, delete, head. You're going to use, you'll mostly use get and post with occasional delete, put, or patch. Okay, and you can look up the verbs online. They're standard named, like there's standard usage of those verbs. And honestly, if you get it wrong, you can, if you just do post for anything that writes, it's not the worst thing in the world. It's not totally correct. It's not the worst thing in the world. I would look up those verbs and try to use those verbs correctly, but it's not the end of the world. The biggest thing is don't use a get to write data. Okay, so we have our post, we have our contact. Now we can just say db dot, this is going to be an insert, actually an upsert record. And I'll type contact model, which I don't think we even need to do that because we're going to infer that from the type. So we have the table name. Then we have the GUID, which we don't have quite yet. We can say contact.id, which is the GUID, and then the record, which is contact. We'll have to make sure our contact model, I believe it does, yes, it does. It generates a new GUID if you don't generate one for it. So that's good. So that'll insert our record. All right, so now we have our two values, get and post. So it's /API/contact for HTTP GET and /API/contact with HTTP POST for inserting the record. All right, now that we have that, we have our API. Now we can actually use our API. This is now going to become our data access layer for a new application. Let's right-click on All right, so we can close this out. And now we have, let's delete our weather forecast, by the way. Let's get rid of that. I do believe that if you go to properties here, I do believe under the debug, it wants to launch that URL. Okay, so it's changed it since I deleted that controller. Normally it says /weather forecast right here as the default, just to have something to go to really quickly. But we're good to go. Okay, so now let's close everything out, and we have our API DB user interface. And in here, let's just go to the index page, and we're going to do a read and a write. Now this web application is going to talk to a different web application. We're not adding any references here to our API. We're going to talk to it across the network. We're not going to link to it in Visual Studio, even though it's in the same solution. I want you to point this out, that even though they're in the same solution, they don't talk to each other directly. A solution is just a bucket to hold conveniently multiple projects open at the same time. It does not make the projects talk to each other. There is no magic there. It's only when you add references that you have the projects talk to each other. And we're adding no references to this API DB UI, which is our Razor Pages application. So instead what we'll do is we will use what's called the HTTP client to talk across the web. However, in order to do that, we need to go to Startup, and in Startup we need to add one more service, services.add_HTTP client. Okay, so this is where we configure our services. This is dependency injection. This is where it creates the items that we then can inject into our controllers. So for example, over here, we see that we're asking for an iLogger of type index model, and we store that value in a read-only iLogger variable. Well, that's being sent from dependency injection, which is configured over here in configure services. Well, I just added the HTTP client to the list of things that gets injected into dependency injection, which means now over here, I can ask for an HTTP client factory. So HTTP client factory. Control dot to add the using statement. And we'll call this HTTP client factory. Control dot to create initialize our field. Once we do that, now we have this factory we can use to get our client. Now, what is this all about? Well, think of this kind of like a web browser. This is our browser. We can then put in a URL and go to that URL. But it's not going to be visual. It's going to be controllable through C#. So we can pull values out of that browser. Now, what that means is we can call our API using that browser. So we're going to do that in just a minute. So let's create a private method in here. This is right behind our index page. So we're not going to go and create a new page or do anything pretty. We're just getting enough of a connection to show you how to get data from an API. So we're going to say private, let's say private void, and we're going to call this the get all contacts. Okay, and inside here, what we'll do is we'll say var client equals HTTP client factory dot create client. That will create for us that browser. Here's the cool thing. It used to be we'd create this using an iDisposable. And what that means is we'd create it in such a way that we'd use a using statement, and then we'd wrap that, and then at the end of that using statement, the client would get disposed of properly. And the reason for that is because if you open up too many connections to a to the web, you'll get what's called socket exhaustion, where we have no more sockets to communicate on. That's not a good thing. And so that using statement would help with that. The problem was that it wouldn't release the connection right away. That's just the way the web works, essentially. And so even with that using statement, we would get that socket exhaustion sometimes. And so then the alternative was to have one client that was open forever, for the life of your application, which might be too long. And so we had to find some kind of balance. And so the HTTP client factory is that balance. When we say create client, it will pull from a pool of clients, and it will create and shut them down as needed. So it's going to do all the maintenance it needs to and handle so we don't have any kind of client or socket exhaustion. So we're getting a client first. Next we're going to do is say response. I'm going to use var a lot here because these values are going to be kind of wacky. Equals, we need to await this. So let's make this async task. So await client.getAsync, and pass in our URL. Let's put our URL, this is the get command, so let's just put it in here like with a string. Normally you'd pull this from somewhere, have it in your app settings.config or something like that, or app settings.json. But in our case, we're going to say HTTPS localhost. We need a port number. Let's go find out what our port number is. Map it back to objects. Ignore the case. Okay, so lowercase first name, or first with a capital N, but first name is going to match capital F, capital M, N, first name. Okay, it's going to match those two up anyways. We're going to map this back to objects. Whenever you call an API, it's going to send just the text. Okay, it's not sending back not sending across the model itself. It's not sending back that structure. It's not sending the interface. None of that goes across the wire. It's just the text in JSON format. Therefore, we have to put it back into a new model. Okay, so now we have our case insensitive is set to true. That's an option. Okay, so we have these option variable. Now what we can do is we can say, let's get back, this is going to be a string value, and that's going to be the response text equals await response dot content dot read as string async. So don't forget the await, otherwise we get back a task of type string. So this response text is that JSON, but it's just one big blob of text. We need to convert that back to object. Or data access library to your front end. There's no reason for that. Don't do it. Because then your front end can bypass your API and talk directly to your Mongo database. That's not a good thing. You don't want that. There's a reason why you have an API. So instead, we need to create a new model. And I talked before about the idea that you will have the same model more than once sometimes. And that's not a violation of dry. Don't repeat yourself. Instead, what it is a reflection that different models have different purposes. The model that's in our data access library, the contact model, that's for the data access library. That's for talking to MongoDB. We don't need that or want that. Instead, what we want is we want a model in our user interface layer, our API for the, I'm sorry, not API, our API DB UI. I probably should name it better. Our Razor Pages application, okay? So let's right click on our project and say add new folder called models. And in here, I'm going to create a model called contact model. Now earlier I had copied that one JSON entry from the web page where I said, okay, here's an example from the API. I'm just going to copy this. So I copied that. I'm going to get rid of public class contact model for just a minute. I'm going to go to the edit menu. Instead of hitting paste, I am going to paste special, paste JSON as classes. This is a really cool function. Click on this, and now look what I have. I have a root object, which that's actually contact model, and then I have an email addresses model and a phone number model. How to get that? Well, if we look at the text, let's just paste it in here. It took this JSON and it says, okay, I know what you need to do here. That's a property, that's a property, that's a property, that's a property, but that one's actually an array of objects with a property inside called email address. And so it takes this and it says, let's try and build a C# model structure out of that. So it does things a little bit differently sometimes. For example, these are all JavaScript style casing, so camel casing. So I want to change that. But this saves me a lot of typing. All right. I'm going to uppercase the address as well, which actually I should do it like this, and then do control dot to rename it. I'm going to change the phone number to be a capital N and control dot to rename that. And now we'll also change the properties themselves, like so. And I'm going to change these to be, instead of arrays, I don't like arrays because they're hard to work with. You have to create them at the size you want. Instead, I'll make this a list of email address and a list of phone number. Now you notice I didn't go into my data access library and figure out and copy and paste these over. You don't always have access to your back end of your API. I'm going to show you an API in a little bit that you don't have any access to the back end. You just have the access to call it. So this paste as JSON is really powerful. You can build out your model and then just tweak what you need to. I'm changing the casing here because that's fine. I have that case insensitive match. Let's change the casing down here as well. And if I do that, it's going to yell at me because I have the class name of email address and the string name of email address, but I normally call my models model at the end. So control dot to rename that, and model here, and control dot to rename that as well. Now I can call it by its name. That's one of the benefits of calling these models, is you can have a string value or some other value in there that has what would be the same name. So email address and email address up here. Now I do want to have these in their own files. I don't want to have all three models in the same file. But the cool thing is control dot, and I can say move type to email address model.cs. And now I have a new class over here. Control dot one more time to move phone numbers. And now I'm all set. I've built out my three models without having to type much at all. It's all just kind of done for me using Visual Studio's power. And that's one of those things people often miss, is they look for tools to make their life easier when Visual Studio has a lot built right into it. Just start getting used to these tools. Add a little bit every day. Don't try and figure out all the tips and tricks all at once and then forget 3/4 of them. Use a little bit at a time and grow your skills in Visual Studio. So we have our contact model now. Now we can come back to our list here and say contact model. Our control dot, add our using statement. Do not add a reference here. It's just add a using for API DBUI.models. And this is going to be our contacts. And let's instantiate it. And the reason why is because, no, you know what? I'm not going to instantiate it. Because if you instantiate it, what you do is you create an empty list. And then if we put values into it, we're going to override that list and destroy it and create and put a new one in it. And so that takes a little bit of extra cycles. So instead, we'll just do a null check. We'll make sure it's not null before we use it. So now we've kind of gone down that rabbit hole getting our model set up. Now we can do something with this response text. Remember, we have a blob of JSON, which is an array of contact model. So we can say contacts equals JSON serializer dot deserialize to type list of contact model, and we pass in our response text and our options, which we created up above. These options right here. Now contacts is a list of our values that have been read from this URL. If we have any, we can loop through them if you want to. I'm going to just put a breakpoint here. Now, in a real web front-end application, if we were doing this on the onGet, what we would do is we would put that into a model that the front end can read and print these off to the screen. We're not going to go there because I've shown you how to take a list of model and put it on the screen and do the HTML for that. And so it's kind of off topic for this video. I'm trying to keep it as focused as possible on just reading from and writing to an API. So I'm not going to show you the, putting on the Razor Pages front end. Nor am I going to show you creating a form to fill out a new contact. We're going to, again, kind of dummy that up. This is not about the user interface. It's about talking to the API. If you want to see how to display information on a Razor Pages application or how to get information from a form into your Razor Pages application, in the last module, we had a number of different videos on user interfaces, and one of those was Razor Page application. And that's going to load whenever this index page loads. When it does, it's going to talk to our API. It's going to, if it's successful, it's going to get the information it needs, convert it to a list of contact model, and put it in contacts where we will read it. If not, don't forget an else statement here for it was not a successful status code. We're going to throw new exception and put our response dot message reason phrase. So I don't think the request message. Well, let's go to the reason phrase and just print that out. I think it's probably good. Just throw an exception of some kind. Now, we can't just launch this page right now because we have our user interface page which talks to our API. Well, we have to launch both. So what we're going to do is I'm going to change this to be this is going to be nope, I'm going to change it to be IIS Express, sorry. If we were to set this as startup project, so let me explain what I'm doing. On the API itself, I'm making sure it launches as IIS Express because only if it's IIS Express can we get the SSL at this port. Otherwise, we port 5000 and 5001 for Kestrel, which Kestrel is when you have where it says sample API, and it will launch that command prompt style window. The problem is you can't launch two things in that command prompt style window for the same ports. There is a way of getting around it, but it's, again, outside the scope of this video. Instead, I'm going to make sure I have it launching as IIS Express here. And I'll also make sure that if I set this as startup project, that it too launches as IIS Express. And make sure that the ports here are not the same ports. Okay, so 44319, that's a different port, which means the two will not conflict. Now that I've checked both of them, I can right-click on my solution. This is one of the very few times where you do something at the solution level besides just add projects. I'm going to say set startup projects. This is the solution level, not the project level. And I get this page right here where it says a single startup project or multiple. I want multiple. I have a bunch of options here, but the option I want is I want to start my my Razor Pages application. So it says start, and also my sample API. But I want my sample API to start first. So I'm going to hit the up arrow and the up arrow again. It's a little weird to watch it because it seems like it's moving weird. But now my sample API is first in this list to start, and then my Razor Pages application. The rest are set to none. I don't want to start up my other user interfaces. In theory, we could start 2 command prompts and an API and a Razor Pages application. So 4 out of 5. You can't start your library. I don't want to do that. I just want the 2 projects to start. Now notice in this window right here, it says multiple startup projects. I could drop down and change that. I'm going to leave it alone and instead hit start. And this will start IS Express for 2 different web pages. First the API, and then it's going to launch the Razor Pages application. Okay? And it just crashed. Excellent. Let's make sure that it didn't hit this. I don't think it did. But let's start again and see if we get a reason why. Okay? Okay, so it has actually gone through here. So the first one had a glitch of some kind. Maybe it's my computer, who knows. But this time, we hit the breakpoint at the end of this response is success status code. Let's go to locals and look at contacts. There's one, and it's Charity Corey, and there's the ID, phone numbers with a count of 2, and in there is 555-1212 and 555-9876. Then email addresses, there's a count of 2 with nope@aol.com and me@timothycorey.com. So it has pulled the record back from the API. There is no reference to the API other than this URL. Okay, there's no direct Visual Studio style reference. So now we know we can read all of our contacts. Let's create a write. So let's start with a private async task, and let's call this, we call the last one get all contacts. Let's call this create contact. And let's not pass anything in. We'll just create the contact right here. So contact model, contact equals new. Oops. Contact model like so. First name equals Tim and last name equals Corey. And then we're going to add contact dot email addresses. I'm pretty sure we did this in the MongoDB UI. So let's just go and look real quick. We did. Let's copy these. We'll have to change user to be contact, but it saves me typing. And I do have to change this to be my information. So tim@iamtimcorey.com and 555-1234. And this is contact. Okay, so everything else matches up, and now we can just create this. Well, how do we create a contact? Well, let's follow our pattern here. Let's copy these first 2 lines, but instead of get async, what we're going to do is look for a post async. Notice there's also patch async, put async, and then up above there is delete async. So you can do all the verbs right here. And it's going to ask for a URI and then content. So content, we're going to pass in contact. And it's going to go, yeah, no, you can't do that because this is content and we want to pass in a model instead. Now you can install a NuGet package that will allow you to post as JSON async, but instead what we'll do here is just say new string content. And we'll pass in our string, which we don't have yet. So we'll get that in just a minute. And then we're going to say encoding dot Whoops. Encoding. There we go. Control dot to add using system.text. So encoding dot, and we want UTF-8. And then finally we say application/JSON. And I'll put this on the screen so you can see it like so. And we need to close out our braces. So that's the call. Let's see if we can't make this wrap a little better. Wrap every argument. That didn't help a lot, but it helped enough. So it's going to say, okay, here's the API or the URL we're going to call for our API. Notice it's the same as the GET, but because this one calls GET and this one calls POST, it's going to call different parts of that same endpoint. So we need to take a JSON string and pass that in. So that's what's saying application/JSON. That's the type of this string content that we're sending through as our content. But we don't have in this. We could add in a NuGet package to call something different called post JSON async, which would convert our object to JSON. But we're going to do it manually. So let's do this. Let's go to the next line here. Actually, let's see if we can do it using the quick actions. Wrap every argument. There we go. Now we can, instead of contact here, we're going to do a little bit of extra work and say new string content. Okay, so this is HTTP content. It's going to say, okay, it's what strings, a string content we're sending across, not a web page. The first thing we need is we need to have our string. Let's just pass in our string itself, an empty string. We'll get back to what that string is going to be. Next, we need an encoding type. So encoding, control dot to add using system.text, encoding.utf8. And that's going to encode it with the text style we need. And then finally, we're going to say application/JSON. If you worked with web at all, let's close our parens here. If you worked with web at all, this is going to look kind of familiar. This is the type of text we're sending across. It could be application/XML, or it could be something totally different. In this case, we're sending application/JSON, which tells the system on the other side, which is our API, it tells it, hey, this is text coming across, and by the way, it's JSON text. That's how it's formatted. Therefore, when you try to parse it, you know how to parse it because you know how to deal with JSON. So, how do we get JSON? Because right now we have an object. Well, down here we have our JSON serializer to deserialize from text to our objects. Let's do the opposite direction. The style or the type of text that is application/JSON. And by the way, this is UTF text, which means it could have a wider range of values than just ASCII characters. So in the US, we're very, very familiar with ASCII characters, A, B, C, D, 1, 2, 3, the standard, what we'd call the standard alphabet for English. However, when you get into other languages such as Arabic or the Asian languages, or even some languages that use the different modifiers to a letter. I'm forgetting the term for it, but the accent characters, okay? They would fall outside the range of ASCII, and that therefore UTF covers those. So it's going to say, hey, we're going to do UTF encoding. It's kind of like the nvarchar for our SQL. So this is going to take our object and convert it to text, JSON specifically, and it's going to post that to this URL. And then we'll just wait the response. Now we could do the if statement like down below. If is success status code, do something. There's nothing to do here. We're just going to, let's just do this. Let's call okay, this is on the front end where you say email address. Aha. And the reason for this is because I just say, go ahead and add a new email address. But I forgot that when it created this model for me, it didn't do this. So I didn't have an instantiated list of email addresses or phone numbers. Let's try it again. That exception page is really nice, though. It takes you right to it. Okay, so we've gone now right to the get all contacts. Let's open locals. And let's try it again. We get right to here without even calling that other method. So I'm guessing that we're actually getting a response issue that's other than successful. Let's run it one more time. Now that I have a breakpoint down here at the end of this call, and I get, it hits here. Let's look at response. Response, 400, bad request. Okay, so it's saying, yeah, no, you can't do that. That's a bad request. And it's not telling us much more of a reason why. Okay, there's the message. The requested URI is API/contacts. And let's look at the content. Header, static member. So it's saying it's the JSON, it's UTF-8, and the results view. Okay, and let's look at the value here, 216. Non-public members. This is just the header information, it's not the body. So let's look and see if we see anything else in here that's of value. I don't see anything else. Maybe content. Nope. So it's not a success status code. There's that false. Okay, so we got to figure out why this call did not work correctly. The first thing I'm going to do is I'm going to look at the immediate window. Have a default GUID. Okay, and that says string, but it's really a GUID type. So let's change it to be a GUID. And then equals new, or equals GUID dot new GUID. Okay, you don't want to say equals new GUID because that would assign an empty value there. That's not what we want. We want this to be a populated GUID. Okay, I think that might have been the problem. Let's find out. So it doesn't do everything for you. I guess you kind of see in there. Put the breakpoint back there. We're going to start this one more time. And it's now hit, the upsert. Let's look at locals. Contact. Okay, we have 2 email addresses. We have a first name, a last name, a GUID, 2 phone numbers, and they look all correct. So what that means is we can take the breakpoint off there. We can hit continue. We can look at response and just make sure that response is success. Reason is okay. So we're good to go there. We can kind of shrink this down now. Take the breakpoint off of there. Go down to here. Now I can open it back up. I'm going to open this back up even farther because the contacts now has 2 records. There's Tim with 2 email addresses, an ID, a last name. We can also go over to our MongoDB Compass. We can hit refresh on our database and see that we also have Tim here and that we have email addresses in place and we have phone numbers in place as well. So we now have a read and a write happening in through our API. Okay, so in our web front end, we are talking to an API for our data access layer. We've done both read and write, and really the other commands are pretty much the same thing. So I'm not going to go into them because this is going long enough. But I did want to show both ends of that, where we have a write and we have a read, so we can use an API as a data source. Now, for the homework tonight, I'm going to show you in just a minute that we're actually going to use a different API instead of one you create. But first, I want to show you today's tip for today, which is every API will be different. And that's something that's hard to kind of grasp at first. People often ask me, well, can you show me how to do this API or that API? Or why don't you demonstrate this API? And at the end of the day, there's so many different ways of doing APIs that it's just not feasible to demonstrate every single type. I've demonstrated probably the most common one you'll use in C#, and it's not going to be even more than about 10 or 15% of the APIs you talk to. But at least you have that 10 or 15% fully covered. However, the principles and most of the code will be the same. It's just you're going to need to adapt to the security and design of each API individually. So don't get so hung up on, I need to know how to do this API. Learn with how to talk to an API in general. That'll get you your 90% of the way. And then you'll need to learn that last 10% for the particular API that you need to work with. Typically, the documentation will help you with that 10%. It won't necessarily help you with the rest of the 90%, but now you already have that, okay? So just relax in knowing that it will be different, and that's okay. You can do this. It may take a little bit of digging. It's not something I can just hand to you and say, there you go, it's all wrapped up nice and neat. Part of being a developer, a huge part of being a developer, is figuring things out. And the natural inclination at first when you're learning is just to say, spoon feed me, give me everything, show me how to do everything. But as you progress, you really need to start taking steps on your own. That's why I don't give you, or at least not yet, I don't give you the homework assignments, not the answers, because I really want you to try it yourself. And if you have the answers, you might be tempted to just look at them and go, okay, I got it. And that's not good enough. You need to do the work to figure it out. And because you're going to come upon situations like this where you don't have the exact API documented, or you don't have a video that shows you exactly how to use the API you need. You need to take the video I just did and say, okay, let's learn this, let's practice this, let's get good at this, even though it's not the right API. Then we can take that and move over to my API and figure out just what's different. Try it just as it is in Tim's demo and see what breaks or what needs to change in order to accommodate those differences in the API you're talking to. And it'll be about 10%. Okay? Now, let's look at today's homework, which is call the Swappy, which is a Star Wars API. It's a fun little API. It's free to use. Don't abuse it. Don't call it 1,000 times a second. Okay? But you can use this as a sample or a test API. Now you can pull up a person and load the models for that person, and then load the models for each film they were in. I'm going to show you that, okay? So we need person, we need the films they're in. So if we go to the Swappy, which is swappy.co, it's not com, it's co. This is a Star Wars API, and it's really well documented. So you can even try it right in the browser. So if I say people/3 and say request, it's going to load up in just a minute. Let's put a slash at the end just in case it needs that. There we go, R2D2. So notice R2D2 here, height, mass, hair color, and all the rest, and the films that he was in. Now they're not in order because it's actually 1, 2, 3, 4, 5, and 6, and 7. This only covers through the 7th film. But then this right here, the film, that's an API call. So if we did /API/films/ let's go with 5/ and hit request, that's going to give us Attack of the Clones, and there's all the information about that. Okay? Now, here's the really cool thing. Remember I said that if you copy the JSON and paste it as models, that paste special, you can create your models automatically? Well, that's what you're going to do here. You're going to come in here and first start with your people. Let's do people/6 and request that. You're going to take this. This is Owen Lars. You're going to copy this whole JSON. Okay, copy it. Then paste it special into Visual Studio to create your models, and then call this API. So the URL is https/ let's zoom in here. https://swappy.co/API/people, and then a number. And I don't care, just hard code a number. So 3, 4, 5, 6, 8, 10, who cares? Just pick one, and then call that and get back the object. Then I want you to look in that object for the films section, okay? And that film section is going to have one or more URLs in it. It's going to be a list of string. You're going to take each of those strings and load up that object. Okay, so call that API and put it into an object. Okay, so that's your homework. Basically, just calling an API for read access only twice. So there's no writes, there's no anything else special, just reading twice. All right, that's all you're going to do. Okay, so that's your homework for this lesson. Once you've done that, once you've practiced it a little bit, maybe try my demo too and practice that as well. But once you're done, then you can move on to the next lesson.